Thank you. Good morning, everyone. Thank you very much, everyone, for being here. It is definitely our pleasure here to talk about the Koalas project that we have started this year. So if you have been already at the Spark Summit before, you have probably seen me talking a little bit about machine learning and deep learning. And Takuya here has been working quite well on Spark.
Yeah, I'm Takuya Ueshin. I'm a software engineer at Databricks, and I'm an Apache Spark committer and PMC member. And mainly focusing on the Spark Seeker and PySpark, and currently I'm a Koalas committer.
So this talk here is about going deeper into the Koalas project. And before I start, who here would consider themselves a data scientist? Okay, wow, a large fraction here. Who here would consider themselves a data engineer? Or pretty much the rest of the room. Perfect. So thanks a lot for being here. I really believe that this talk is going to address some of the needs that you have. And this is not meant to be a remake of the demo. This is meant to be more technical and go into the details of the Koalas technology so that you can understand what you should expect from it at this point and where it is going into the future. And also, we want to show you some new features that I think that you'll be very excited about. So if we want to retrace briefly why we started this project, if you look at the education and the journey of a typical data scientist, you probably have started at some point by learning to do data science on some small data sets, either through MOOCs or by reading some books or by reading some blogs and going to universities. And all of that was being done using Pandas, most probably. And you started probably to work on small data sets, or even if you just want to analyze some small data set, you're probably also using Pandas. And only when you want to switch to larger data sets is typically where Spark comes into play. So I don't need to tell you that Pandas is very popular in the Python world. It is pretty much as old as Spark. It was authored by Wes McKinney in 2008. And nowadays, it is really the standard for doing data science and data manipulation in Python. And I think one of the reasons for its very large success is because it integrates all the standard tools from the Python ecosystem. It relies on NumPy for doing numerical calculations. It uses Matplotlib for doing the plotting, and also it works on and it can ingest and transform data set of pretty much any format. And on top of that, it provides a pretty complete toolbox these days with statistical analysis, time series analysis, all the tool that you would need for dealing with missing data, and so on. And if you look at Spark so far has been very complementary. It is nowadays pretty much the standard for doing the data science and the machine learning at scale, well, for doing data science at scale, and for doing large-scale data processing in general. And also, one of the reasons why it is so popular is because it is an integrated toolbox that includes streaming, machine learning, ETL tools, all into the same roof. And also pretty much the same at the same time, it was created as Pandas. And I think to me, one of the reasons for its success also is that it has APIs for different languages, which means it caters to different communities. So Python with PySpark, the Scala API, which is the default, but also SQL and R for people who want to do more traditional ETL. And if you look at the concept of DataFrame, when we thought about it in 2013, it was based on the same notions as Pandas, but the implementation differs a bit due to the history of the two projects. So the syntax of the two data frames in PySpark and Pandas are pretty similar. You can access a column using the same syntax, but afterwards, a lot of subtleties come from the underlying implementations. In the case of Pandas, the data frame is mutable. You can update columns or data in place. While in the case of Spark, all you can do is chain transformation against immutable data frames. which means that if you want to add columns or rename columns and do some other operations such as counting values, the syntax will be pretty different. Not only do this difference into mutable versus immutable, but also the syntax of Spark DataFrame was more heavily inspired by the SQL syntax. And you see that especially if you want to do operations such as counting the different values you have in a data set. In the case of Pandas, it is directly one operation. In the case of Spark, you need to express that in something that is closer to what you would do in traditional SQL. And when you look at when we looked at what people were doing in the Python world, we saw that essentially Spark could not be necessarily PySpark could not necessarily be as natural for people who are coming from the Spark from the Pandas ecosystem, because if you take a short example, where you want to simply read a CSV, rename some columns, add some columns, it is a bit more cumbersome and verbose to do that with PySpark. This is why we created this project Koalas, which we started about a year ago and which we announced in April. And Koalas is a pure Python library, so you can install it just like any other Python libraries. And it really aims at providing all the Pandas API on top of Apache Spark so that it gives you the scalability that you would want with the familiarity of Pandas. And it has been, these days, very quickly gaining traction. I think I'm very pleased to see that now we have more than 20 contributors contributing to the repository. And we have gone above the 8,000 daily downloads on average. And the reason why I think it is gaining popularity is because it really enables you, as Brooke showed you this morning in the keynote, how you can take your existing Pandas code, and by doing some very minute modifications, you can then convert that to something that runs on top of Apache Spark. So there's still a couple of differences, and this is why we wanted to do this talk, to explain really how it translates, how these differences after that translate into the code that you may want to write. And most of these differences come from the fact that fundamentally Spark is more lazy. All of the operation that you do in Spark, well, most of the operation you do in Spark do not get evaluated immediately, but only only happen when you want to do side effects, whether it is by evaluating some pointed values when performing actions, or for example, by writing data frames to external storage. Another big difference comes from the distributed nature of Spark, in which, because Spark does not maintain the order of the rows. If you are coming from Pandas, Pandas essentially behaves as an array of rows. While Pandas think of all its data as simply being a bag or a multi-set of rows. And because of that, there's no natural ordering of the data. And finally, there is, of course, difference if you want to work at scale. So, Takuya, do you want to?
Yeah. Okay, thanks, Tim. In my part, I'd like to talk about the current status and measure new features, and also roadmap, as well as some technical topics. At first, I'll show you the current status. So far, we've been making release bi-weekly, as Tim said. And the current version is 0.20.0. Thankfully, we have more than 20 significant contributors and have a lot of daily changes. Koalas already covers equivalent Pandas APIs at 60% of DataFrame or series APIs, and 60% of group by APIs, and 15% of index APIs, and a lot of general functions like to datetime or get dummies and so on. For the new features, we implemented plot functions, and they already cover 80%. And also, we implemented the Spark-related functions. For example, For the specific data type, Parquet or CSV or JSON, we provide to Parquet, read Parquet, to CSV, and so on. These are available also in Pandas. But for the general data format, we provide to Spark IO or read Spark IO with specific, you can specify with the format, which are available in Spark SQL. Also, if you already have a Delta Lake, we provide a toDelta or read Delta functions. Also, you can run SQL sentences with the existing Koalas data frame, and you can also cache the Koalas data frame the same as the Spark data frame. And also, we started support for the multi-index columns. The coverage is 90% of the existing APIs, and will be complete soon. Finally, we provide the options API to configure Koalas behavior. You can now configure, for example, how many rows Koalas display in the console or Jupyter Notebook. Or you can also configure the default index type, which I will talk later in this session. Let's see some demo from our 10-minute tutorial. This is a Databricks environment, and it can manage the cluster here and work the cluster behind in the background. We can install the Koalas with this command. And to enable the Koalas, we just import the library, Databricks Koalas. And we usually use KS as the alias of the library. At first, I'd like to show how to create a series. The syntax is exactly the same as Pandas series, and the result is like this. Notice here that it runs the Spark job, which means Spark runs in the background instead of the Pandas functions. Also, here's the example of the creating the data frame. The syntax is also the same as Pandas one. And the result is like this. See this here again. It runs the Spark jobs. We can create the Koalas data frame from Pandas data frame as well. By the way, in this session, I use the PDF for the Pandas API, Pandas data frame, and also for the Koalas data frame, I use KDF, and for the Spark data frame as a SDF. Here is the example of the Pandas data frame PDF. And you can call from Pandas function. Then you can convert the Pandas data frame into the Koalas data frame, and the result is exactly the same as the Pandas one. But here you can see the Spark job, and it means it runs the Spark job. It runs Spark in the background. Also, it's possible to create a Koalas data frame from Spark data frame. This is an example of the Spark data frame, and you can call the toKoalas function. toKoalas function is automatically attached to Spark data frame when Koalas is imported. Then you can call sdf.toKoalas. Then we can get the Koalas data frame. Koalas data frame has the index and columns, like the same as the Pandas data frame. And if you want to convert the data into the NumPy array, you can call kdf.to_NumPy function. But be careful about this is this function, and also Koalas data frame has the two Pandas function. Those are collecting all the data into driver side. So if driver doesn't have enough memory, out of memory error will occur. So be careful to use those functions. Now, next, let's see some example from the some operations. Koalas data frame has a mean function or some other statistic function like sum, count, max or mean, something like that. Also, you can call describe function to show the quick summary, quick statistics of the data frame. Of course, we have the grouping functions, and we can call the group by and sum and other grouping functions. You can also specify the multiple columns as a group by key here. Then result will be like this. The next example is plotting. We implemented the plotting function, and this is an example of one of the plot function. This is a line plot. Also, you can call the plot functions on the data frame. The result will be like this. Finally, I'd like to show the example of the data input and output. This example is the for Parquet. We provide the toParquet or readParquet function, and with the specified path, the Koalas data frame writes the data with the Parquet format into this path, or reads the data, reads the Parquet file from this path. Also, we provide the toSpark IO and readSpark IO with the format. This example shows that we can use the ORC format with the Spark IO. Yeah, ORC file format is not available on the data frame. Yeah, but Koalas can handle those file formats. Okay. We have guest blog post from Hyperloop 1, and they show more than 10 times faster with less than 1% code changes. Please read the blog post for more detail. I'd like to move on to the technical topics. At first, I'd like to talk about the internal frame. Internal frame is the internal immutable structure to hold the current Spark data frame and some metadata to provide a good mimic of Pandas data frame. It holds the mapping from the Koalas column names and Spark columns. Koalas data frame column names does not always equal to Spark data frame, because now that Koalas data frame supports the multi-index columns. So we should manage this metadata. Also, we have Koalas has the mapping from Koalas index to Spark columns. The combination of the Spark data frame and the metadata will provide the mimic of Pandas data frame. Optionally, but importantly, it provides the way to convert from Pandas data frame to Spark data frame and extract some metadata, and vice versa. The basic structure is like this. Koalas data frame has the internal frame, and the internal frame refers the Spark data frame and holds some metadata named column index or index map and so on. If a user calls some API, Koalas data frame updates Spark data frame and metadata and creates or copies the current internal frame with the new state, and then return a new Koalas data frame. Sometimes the updates of Spark data frame is not needed. For example, if we call kdf.setIndex, we don't need to update the Spark data frame. In that case, just update the metadata and return the new Koalas data frame. On the other hand, sometimes Koalas data frame updates the state in itself, not create the new Koalas data frame. In that case, for example, kdf.drop_na blah 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 impress equal true. In this case, Koalas doesn't return the new data frame, but update the state itself. In any case, Koalas data frame never mutates internal frame, but creates or copies the current internal frame to keep it immutable. Next, about the operations on different data frames. Here, for example, we have a data frame df, and we can do some operations like df.a plus df.b, and so on. On the other hand, when we have two data frames, df1 and df2, we naturally want to do some operations on that too, like df1.a plus df2.b. But currently, Koalas doesn't allow these operations by default. This is because Koalas backend is Spark data frame, which doesn't have these operations. The equivalent Spark codes are like this, sdf.select blah blah blah. But on the right side, it includes sdf1 and sdf2. If we call this, execute this command, we will get the analysis exception. We can't execute such code on Spark. To make it possible, we need join operation with the index. As you know, join is very expensive, so Koalas doesn't allow it by default to avoid unexpected expensive operations. If you must have such operations, you can turn it on by setting this option to true. Next is the default index. As I said, Koalas manages a group of columns as indexes, and they should have behave the same as Pandas one. When you have Pandas data frame and convert to Koalas from Pandas function, then Koalas automatically picks up the metadata, but other data sources don't always have an index. But if the index is not specified, Koalas will automatically attach default index to the data frame. And the Koalas provides the three types of the default index, which has pros and cons. So we need to decide which index we should use. The three index types are sequence and distributed sequence and distributed. The sequence is the default value. This guarantees the index increments continuously, but it uses the no partitioned window function internally. So it means all the data needs to be collected into a single node. So if the node doesn't have enough memory, out-of-memory error will occur. The second option is distributed sequence. Once the index is attached, the performance penalty is not that big compared to the sequence type. It doesn't collect all data, but when attaching this index, one Spark job runs. Also, notice that in some cases, it doesn't guarantee continuously increasing numbers. The third option is distributed. It has almost no performance penalty and always creates different number, but the numbers have an unexpected gap. It means this index type can never be used as the index for operations on different data frames. We can't know how the join works. But if the index is just needed to order rows, then this index type would be the best choice. Please see also see this user guide for more detail. Finally, I'd like to show you the current roadmap. We will continue improving Pandas API coverage, including rolling and expanding functions. Those are window functions and have a lot of functions on the window. The second, we will support categorical data types. Currently, Koalas supports only compatible type with Spark's data types. We will implement the mapping between Pandas data types and Spark data types. The third, we will add more time series related functions. There are a lot of data types for time series related functions. So after the infrastructure for the data type mapping is implemented, we will be able to start that. Finally, we will consider more about performance. Currently, at some point, we can see the overhead in Koalas layer. Also, each existing function might have more optimal implementation. Okay, please get started soon. You can install Koalas by PIP or command. If you don't have a Spark cluster yet, you can also install PySpark with a PIP or command. Also, please take a look at the documents and follow the updates on GitHub. There is a 10-minute tutorial in a live Jupyter notebook available, and you can also easily import it into Databricks notebook. If you have any suggestions, questions, or feature requests, please feel free to file an issue on the GitHub issue page. Your contributions are always welcome. Please take a look at the contribution guide.
Okay, so if you want to know more, I think we have just a few minutes after that for question. If you want to know more about how to use it or know more about the inside of the technology, we'll have a tutorial this afternoon at 2:30 in room G104, which I think is not too far over there. And after that, if you have more questions at 4 o'clock in the expo hall, Takuya, myself, also, and all the other developers will be there if you want to have more details about Koalas. So thanks a lot for being here. And we're happy to answer a few questions here. Otherwise, there will be some time at the Ask Me Anything session.
Yeah. So we have a few minutes for the questions. Just you can raise your hand, and I will walk up to you with the microphone.
Thank you for the great session. Databricks has a display function which works pretty well. Is it supported with Koalas? To use the display function on the Koalas data frame?
Well, you did use the display function, right?
Yeah.
So.
Okay, so it's dynamic. So the plot function works, but also the display where you dynamically interact with the data. Okay, great.
Yes.
Thanks.
Hi, thank you for the question, for the session. What is the current parity between the API of Pandas and of Koalas? Like, is it 100% in terms of compatibility?
So, yes, so, do you want to go to, so it's about, so for the main functions, it is roughly covered here. Here are some numbers. And the two domains which I think still like a bit behind are the indexing. Here there are some the basic pieces, and the multi-indexing needs to have more work, and also all the work around time series. So if you're not sure about one specific function or some option on a function, we have open tickets for every single option that is missing. And also, if you're trying to take some code from Pandas and you want to use it in Koalas, for every Pandas function in the main classes, such as DataFrame, index, and so on, it will throw an exception indicating the status precisely of what option is supported if it is not supported.
Thank you so much for the session. I had a question. So Spark, in its backend, has different types of joins. So like a shuffle hash join or a broadcast hash join. So when we join the data sets from Koalas, so is there an option that we can choose those types of join? For example, there is a broadcast function when we use the Spark API. So can we specify these types of joins in Koalas?
Yeah. Actually, currently a very naive implementation and just call the Spark sequence join internally. So Spark will decide the join type. And currently we cannot specify some join hint or something right now. So it will be very good to have functionality. So we will consider about that.
Yeah. Okay.
Also to complete on that, in general, as you have seen, it is not a good idea to try to mix different types of columns together. If your column is more about the merge function from Pandas, then yeah, we're looking at how we can expose all this information from that would be more relevant to Spark about the algorithm to pick.
Hi, thank you for your session. Recently, we've been experimenting with Apache Arrow and PyArrow to increase the speed from Spark DataFrames to Pandas DataFrame. Is it in any way related to Koalas, or can it be used in conjunction? Or?
Well, under the hood, it is using Arrow.
It is using Arrow?
Yeah.
Okay, so there's no need to use it with it together. It's already under the hood. Okay, thank you.
So I think there's some. I think you had some performance ideas on that. For using Arrow. I think there are some options that you can specify to make sure that Spark always use Arrow when you want. That is something we can probably cover later at the Ask Me Anything session. Mm-hmm. All the performance tips. Yeah.
All right, thank you.
Thank you very much. I have a question regarding the file types and the data sources. In the keynote we saw, for example, that it could be, the Koalas data frame can be saved as Parquet. Do you support some granularity there, like partitioning and other tweaking?
So additional options, right?
Yes.
Yeah. Currently, I introduced some function, read Parquet or something. Each function has the options keyword argument. Then you can specify exactly the same name with a Spark data frame writer or reader. So you can specify such option with these functions.
Hello? Hi. So I saw before the plot functions. I just want to know, what is the relationship with other Python packages, such as Matplotlib? Is it fully functionable with Matplotlib? Is there any limitations?
Yeah, that's a very good question. So here, the goal is to implement the small subsets of plotting that Pandas naturally supports inside its own API. It is very hard to try to make sure that the data frame produced by Koalas is compatible by everything that Matplotlib expects, mostly because Matplotlib assumes that the data is going to be in a certain tabular array format and can do efficient manipulation into it. In general, actually, Matplotlib will take the input dataset and convert it to an NumPy array, which here would negate a lot of the benefits that you have from that because it would collect all the data. So this is why we try to just make the plotting available in Pandas available. For more complex plotting, after that, there are so many trade-offs to do between the kind of plot that you want and also the fine granularity that you expect versus having something more coarse that samples some data, for example. For that, some other solutions which are more catered for this kind of large-scale plot visualization would be, I think, preferable to Matplotlib. I'm thinking here about something maybe like Bokeh or some of the other data visualization systems, which are more used to behaving with large data sets like this.
Hi, thank you for the talk. I have a question regarding the apply function on dataset. Is it supported when I have my custom function?
Apply. Yeah, some function can be already. We already implemented some function like the apply or apply map, and so on. So there might still be missing functions. So if you want some other functions, then you can file the issue on our GitHub issue page. So please check the functions.
So one thing which I can add here that for map, apply map, and so on, we support a subset of everything that Pandas supports. One big difference is that Spark needs to know the return type. So you need to add hints to the output of your function. And there is some documentation in the Koalas documentation about how you can do that. If you use Python 3, Python 3 already has all the type hinting that you want, and it is fully integrated with that. One big difference I think that users have complained about is the lack of support for the NumPy universal functions, ufuncs. I think so. We are looking at how we can incorporate that directly into the apply map. Otherwise, you would have to wrap it, add a hint, and then it would work.
Yeah.
With a caveat that if you want to use a function, it is much better if this function return series or can work directly on series or data frames. Otherwise, you have a much higher penalty of data transfer if you work on a row-by-row basis. This is something that you have a bit less usually with regular Python, but in Spark it is much more pronounced.
All right, let's thank our speakers again and give them a round of applause. Also remember to rate the session in the app, and we're going to have the next session in 10 minutes.